space, another frontier. These are the voyages of the YouTube channel smAsho. Its continuing mission: to explore strange new articles, to seek out new life and new intelligent ideas, to boldly go where no YouTube channel has gone before. All right, enough of that stuff. So we got the sun in 193 angstroms here. See very low levels of activity, and we do see a pretty decent sized coronal hole here associated with the South Pole. Now, for those of you who watched yesterday, it looked like some data got scrubbed. Keep in mind, this is still on the 304 angstroms view right now in real time, although you can also go and look this up in further detail by looking at one of the links on the main SDO page. Anyway, we figured we'd feature this again in animated form. One thing I would note here that we didn't really look at yesterday is that there is apparent magnetic interaction around it. You see, it looks like there's like a triangle around the tip of this object here. It's probably plasma coming out of one of these filaments, which nearly made it off of the sun, but not quite. It looks like it's going south to north, so maybe it got ejected out of this filament and was kind of an in-betweener there where it couldn't quite make it out of the corona. So in any case, it's only there for one frame. I don't know why the timestamp changed. We clearly did see it at 22:43 originally. In any case, there's a close-up of that. If you want to look it up yourself, these images are between 2200 and 2300 on February 8th. And that anomaly shows up right to the east of this hot spot. We're showing you this view here because we don't see any evidence of this at other wavelengths. There's the same time frame at 193. You don't see anything there. And we did look at all the wavelengths. And there's that again at 304. See, it does look like it's interacting with the plasma, indicating that it is in the corona and not some sort of a foreground object. And let's just take a look at 171 angstroms here for a minute. We see some major filamentary activity going on here in the northwest. Basically a filamentary solar tornado plasma dance there going on. Pretty awesome. That's probably about 6 Earths in diameter total size of those filaments. And here are the magnetic lines, also at 171 angstroms. It looks like the North Pole coronal hole is getting a little more symmetrical again here. You see, it's magnetic lines are coming out of that more normally, more similar to the South Pole. So it looks like some of that asymmetry in the North Pole coronal hole is now gone. How about some real-time solar wind? We are unable to scroll. Oh, now we're able to scroll. Cheers. So we see only a tiny little connection there with the coronal hole systems. Maybe one there also. No real sustained connection to the coronal holes. We see a solar wind density of 6.71 protons per cubic centimeter and a solar wind speed 458 kilometers per second. So it looks like things are calming down a little bit. Let's look at some more data. How about a little bit of spaceweathernews.com? Please load. Thank you. So the X-ray flux is flatlined. And you see the magnetometer here. We're going to be in smooth sailing mode. In fact, we're going to probably see a weak range in this for the next couple days. KP index is up to 3, surprisingly. So we wouldn't be surprised if that dropped down. barring no other incoming solar wind. Electron flux is looking pretty smooth here, although we do see a disparity between the two satellites because we have two satellites measuring that same information there. Also, for the non-regular viewers, please know that the NN and MM means midnight local time and noon local time for the given satellite. I don't know which satellites those are. Those are like the 14 and 15, I think. Charging hazards are very minimal. And there's your F2 layer, which is looking pretty normal here. At least not as discharged as it was an hour ago. Actually, it was kind of heavily charged down here. And that's kind of dissipating a little bit now. There is a pretty big charge disparity between the South Atlantic anomaly and the incoming solar protons. Moving on. And we'll check out quakes.globalincidentmap.com. I'm going to go back 12 hours here. We've got a quake here that's apparently nowhere. Not sure where that is. Okay, that's in Iran. So I'm not sure if that's two quakes. So that's just one quake there. It's just listed weird for some reason. So a 4.8 in Iran. There's a 5.2 in the Philippines. There's a location of that one. Ring of Fire. And we got a 4.8 south-southwest of Sigave, Wallace, and Futuna. Okay, if you say so. I never heard of it, but check it out. It's by Fiji. And by the way, the warning area for a 7.0 plus is right about there. What else we got? Chile, a 4.2. So that area should remain on alert for a mid-level 4. 4.6 in Indonesia, 5.0 in Indonesia, 4.5 in Indonesia, and a 5.2. So earthquake uptick there in Indonesia. Check out where that's located. Bit of an earthquake swarm there. Not a significant uptick, but an uptick for sure. Another one in the Philippines. Also a 5.2 in India. 4.5 in the Mariana Islands. Kind of southeast of Japan there. And another 4.6 in Indonesia. So, small uptick in quakes there. No really significant coronal holes coming in, so no significant uptick in warnings. Let's look at why it's going to be smooth sailing here, magnetically speaking, for the next few days. It has to do with the magnetic environment, so let's look at the Gong 2. Now, you can see stereo A over here, stereo B over here, and the heliosphere, the current sheet in this area. Now, if you look at the incoming magnetic environment, it's a bunch of jumbled up plasma there, which equates to weak fields. The opposite of what we get when we see a direct connection. So, when the Earth's connected to the Sun in an area like this, we see strong magnetometer. And when the Earth's connected to a jumbled up field of plasma like this, we see a weak GOES magnetometer. So until this unless something changes within the heliospheric current sheet, and keep in mind it can instantly with no warning, until the crossing here happens, where we're more associated with the North Pole than the South Pole, we expect to have magnetic smooth sailing as the magnetosphere connects to these areas. Hope that made sense. Moving on. And since we have 21 tabs open here, we're going to have to try to truncate this a little bit. Here's the magnetosphere movies. Here's the velocity. Here's the density. You see, actually, the density around the planet's pretty low right now, much lower than it was yesterday. Again, remember, white is low density and blue is high density. Here's the pressure. And we'll let that play through. It refreshed just to inconvenience us. All right, there we go. And there's the most current. Next, let's look at ground level geospace magnetic perturbations. We'll look at the poles first, where our field-aligned Birkeland currents arrive, energizing the planet. And let's see how it translates to the rest of the globe. And we see standard issue magnetic leakage up into the Indian Ocean there, toward Australia and India. And we see evidence of two magnetic poles in the northern hemisphere. A stronger one over Siberia and a weaker one over Canada. Moving on to volcanodiscovery.com. Volcanoes today. What do we have? Looks like Shivaluch is back at it, emitting a 13,000-foot ash plume as it calms down. Sakurajima exploded, producing a 6,000-foot ash plume. Tukono, 8,000-foot ash plume there. Popocatépetl, volcanic ash disp, I guess dissipating. Fuego, volcanic ash emission observed. Revenador, satellite detecting volcanic ash there. Sabancaya, intermittent emissions of gases and volcanic ash. And Planchon Peteroa, the biggest volcano of the day, producing a 16,000-foot volcanic ash plume. Next, we're going to classify a galaxy here before your very eyes. Zooniverse.org, one of the largest citizen science projects in the world. Why is this a thing? Well, it's because there's too many galaxies out there. Computers cannot do the visual analysis that your brain can. So head to zooniverse.org and perhaps get yourself published in a scientific astronomy paper. Here we have a pretty boring galaxy. It's a semi-edge-on, semi-cigar-shaped thing. Let's say that it's got features. By the way, create yourself a login here, as we did. Yes. So, what else do we have? Is it an edge-on disk? Close, but no cigar. Pun intentional. Is there a bar? No, sir. There is no bar. Is there a spiral arm pattern? Not really. And is there a central bulge? There's a small central bulge. We'll include that. Is it disturbed? No disturbance. Any odd features? No, I don't think so. It's pretty basic. Nothing unusual. Alright, if this one's cooler, we'll do this one. Well, it's got an overlap. Let's do it anyway. So this one's smooth. It's not completely round. Is it merging or disturbed? Nope. Any unusual features? We've got overlapping. And there's two galaxies classified. Galaxy Zoo, zooniverse.org. Do some actual astronomy. no degree required. Next, let's look at some cosmic ray sources. We got some anomalous data in Athens to kick off our cosmic ray segment. Check it out. It looks like the monitor was offline. Not sure what's going on there. If anybody knows, leave a comment. Here's Mexico City. Here's Moscow. And then we've got Oulu, DOMC Antarctica, and here's DOMB Antarctica. Nothing too serious. We wanted to show you the data anyway. And by the way, we'll leave links to this giant cosmic ray network site. Next, let's look at some transients. For those of you not aware, Sagittarius A star is the core of the Milky Way galaxy. And we actually saw the largest, the most energetic transient out of the galactic core since New Year's, about 2 days ago. So there you see that transient there. Here's the historic data since 2005. And you can see the largest ones we've had recently. Obviously, the largest one we've ever seen was around 2011. And the largest recent one was right before New Year, right here. And we just had a significant transient there about 2 days ago. Next, we'll look at Cygnus X3, massive X-ray binary consisting of a Wolf-Rayet star and some other massive radio source. Some people call it a neutron star, black hole, quark star, mini, micro, blazar, quasar, all kinds of things. It's just a massive radio source, whatever it might be. It's also the tail of the swan in the constellation Cygnus. And at the other end of the precessional cycle, it's the Earth's celestial North Pole. Now, if you look at what's been happening since New Year, this has been dropping down. And this is a known thing. Cygnus X3 does this. When you get these drops, it drops down and then it gets into a big spike of activity. This is the normal thing. If you don't know about Cygnus X3, please read about it. It's a one hell of a bizarre X-ray binary. And there's the transients. So once we get down to this zero line here, we can expect to see this to kick back up again. And keep in mind, this is a very, very reliable cosmic ray source. Next, we'll look at the transients from Cygnus X1. Now, that Cygnus X1 is the famous, quote, black hole, end quote, that Stephen Hawking and Carl Sagan bet on, whether or not it's a black hole. You can see just in 2019, this has kicked back up into activity. Also located in the constellation Cygnus, Cygnus X1, the first establishment cosmological black hole that was agreed that it's a, quote, black hole, end quote. And the reason we're calling black holes, quote, and quote, black holes is because black holes aren't science. Next, let's look at supernova 2014J and galaxy M82. See the transients for that. They only go back to 2014 because that's when it was discovered. So it's at a pretty high level of activity here. But, you know, when you only have 4 years of baseline, it's pretty hard to say what's going on with it. The highest transient we measured there was right at the end of 2017, it looks like. By the way, this is a very famous supernova, 2014J. Here's an image of it, and we will leave links. Located in the edgewise viewed galaxy M82. A very massive, massive elliptical galaxy. And there's where that supernova is located. If you have some sort of an object in the sky that you'd like to see the transient analysis of, we'll leave a link to this too. Hundreds and hundreds and hundreds of transients are being monitored all the time. All kinds of objects from the Vela pulsar to who knows what else. So if you've got an object that you want to look at, for instance, Cygnus A, the massive radio galaxy. Let's just search for Cygnus. There we go. Come down. There's a lot of radio sources in the Cygnus constellation, by the way. Here's Cygnus A. Scroll over, click on it, otherwise known as... Whoops. Well, we've mucked that up, didn't we? All right. Cygnus A. Where'd it go? All right. So there's Cygnus A, otherwise known as the catchy name of 3C405.0. Geez, that thing should have a better designation than that. Why? Because it's the second most powerful radio source in the entire sky. So here's the transients from this. We don't see anything too special. For those of you not familiar with Cygnus A is a massive elliptical radio galaxy located an estimated 730 million light years away. So that far away, yet it's the second most energetic radio source in the entire sky. Here's a great image of the radio jets. You can see the supermassive radio source here in the middle is creating a magnetic environment so strong that no stars can form any of these areas. And then you get ultra hot spots out here where the energy is getting low enough for matter to act like matter again. Cygnus A, super interesting radio source. And galactic nucleus. Links to that shall be in the description. Don't worry, you're not caught in a time loop. We've gone back to where we started, to the sun in 304 angstroms. See big time filament activity all around the edges of the disk there. And you hear me thanking you for viewing. Thanks, subscribers. I don't know what it takes to get to 1,000, but it doesn't really matter to us because we'd be making these videos with 0 subscribers. But we appreciate you viewing nonetheless, because people commenting especially helps our channel to become more sophisticated. So please don't forget to like and subscribe if you haven't done so already. And remember, when you're finding the anomalies and telling people about them, don't drink. And if you drink, find the anomalies and tell people about them anyway. Just don't drive.